Hello, everyone, and welcome to today's session, Choosing the Right Power Connector for Your Application. My name is David Zimmett. I'm the president of Orion Technology, or Hirose's representative in Canada since 1995. I'd like to introduce you to today's presenter, Dave Gallagher. He graduated summa cum laude from Southern New Hampshire University with a Bachelor of Science in Business Studies in Operations and Project Management. He also holds a Data and Telecommunications certificate from the University of Massachusetts Lowell. Dave has been with Hirose for almost 4 years. Hello, David.
Good morning, everybody. Or I should say afternoon now. It's afternoon time.
Correct. So prior to beginning, we would like to ask you a couple of questions. At the end of Dave's presentation, we will have a Q&A and would love to hear from you. You will also be able to download a number of documents related to today's webinar. A recorded version of this webinar will be available on Orion Technology's website. And finally, when the webinar is over, we would truly appreciate your feedback about today's session and future webinars we will be holding.
Hello everyone, and thank you for joining today to learn more about selecting the right power connection for your application. My name is Dave Gallagher, and I'm the North American Eastern Regional Sales Engineer for Hirose Electric USA. Today we will discuss some of the common questions related to power connector selection. I will cover internal, external, and even board-to-board power connectivity. Let's start by taking a closer look at the different sizes of connectors. Whether we're talking about micro power connectivity to tiny sensors, such as these here, or we're talking about big batteries and heavy lift motors, the basic principles will remain the same. There are some common questions that need to be asked if we are to select the right power connector. The factors that impact the selection of a power connector can usually be reduced to the following items: the current or amperage for your application, the conductor count, the voltage rating or any creepage or air gap requirements that you might have, or safety ratings regarding voltage, the environmental requirements for your applications, maybe an IP rating, the application information, maybe there's special mounting or space restrictions that you have. First, we'll start off by talking about the current flowing through the connector. Part of this is going to be related to the actual amperage of the connection, and part of it is going to be related to the wire gauge. When working with customers, I usually like to start with the wire gauge. Even though it is very important to know what the amperage is, I like to start with the wire gauge because no matter what that amperage is, the contact needs to crimp securely to the wire. So if you are using an 18 gauge wire, but are only using 1 amp worth of power, we will select the smallest connector that has support for the 18 gauge wire. This will save you both space and cost. Understanding the required current is the second half of this question. What is the peak amperage needed for the application? Are you running current over more than one contact, maybe multiple circuits? Are you dividing a higher current need across more than one contact, but it's only a single circuit? For power connectors, we need to understand that application and how that current will be distributed across the connector. If your current is running over a single contact, then this rating is simple and listed in the datasheets. However, let's say that you plan to divide a single 10 amp circuit across more than one contact. The initial thought is you only need 2 5 amp contacts, but the reality is a bit different. When current is divided, we will not know exactly what the contact resistance is at each connection point. This is not the same as drawing 2 completely independent 5 amp sources. 2 side-by-side contacts could have slightly different contact resistance values. How does this impact the rating, you ask? Well, the electrons will travel over the path of the least resistance. This means that contact A may be 60% of the power in our example, 6 amps, and contact B may only be carrying 40% or 4 amps. Suddenly that 5 amp contact that you initially selected is being pushed too hard and overheating. As that contact heats up, yes, we know that will produce a higher resistance value, but the core problem still exists, and we need to be mindful of it. We never want an overheating contact. Connector and system failures become a real possibility in this situation. This brings us around to talking about the D rating of connectors. Amperage ratings come from the temperature rise of the contacts and the ability of that contact and the connector to dissipate that heat out to the environment. This gets a bit complex because there are a few factors that play into the ratings. First off, most connectors are rated based on a fixed ambient temperature value of 25 C and an expected temperature rise of 30 C. A chart, like this one here that we see, is what you'll typically find with one of these connector ratings when you're looking at the power capabilities. Note the 25 C value. This can be difficult to define since not all users can keep the ambient temperature range at 25 C. So this brings up a D-rating curve to help out a bit. A D-rating curve looks at the amperage rating as the ambient temperature rises. We can see here that as the temperature in the ambient environment rises, the amperage rating for the connector will fall. If your ambient temperature rating will be higher than normal, then you'll need to consider the D-rating of that connector in order to accommodate that limited heat dissipation to the environment. Here we see them side by side for the same connector. The dotted line shows a safety D rating applied by Hirose of 80% from the initial tested value. For most users, the standard product ratings will be fine. However, your application may push the temperature envelope or even the current rating, and if that's the case, it's always wise to dig a bit deeper. Here we can see a typical rating chart for our DF63 series board-to-wire connectors. As you can see here, there are different values depending on the contact count and the wire gauge. Hirose has already gone ahead and determined those test results and provided a guideline for that D rating of the connector. Using our earlier example of a 10 amp current need over 2 contact 18 gauge wire, we can see that this DF63 is perfect. It's the right connector for you to choose. If you're in a situation where you're splitting a single higher current, maybe in a smaller connector over multiple contacts, that's when we need to consider additional D rating beyond what you see in this chart. And that value could be up to 1/3 the original contact rating. Wow, we've spent a ton of time on the amperage rating, and rightfully so. It is probably the area I get the most questions on. Now let's talk about a few of the other design considerations, starting with the voltage. Voltage ratings seldom come up as an issue on power connectors, since typically when the voltage gets higher, the current ratings are also higher, resulting in a physically bigger connector, and hence a higher voltage rating. The two key values in a power connector when determining voltage is the air gap between the contacts and the creepage distance. We like to ask what the voltage is and make sure it is within the ratings of the existing target family that we've been working with you based on the previous current discussion. Honestly, I seldom have issues here, especially with the Hirose connectors. If you take a look here at this picture of the DF63 series, you'll note that there's internal walls on the connector in between each contact that drastically increase the creepage distance and the air gap as well. I occasionally have users that don't need the high current of a larger connector, but they do need a greater contact pitch due to isolation requirements. Now, if we were to go back to our DF63 samples chart that we looked at earlier, we can see here that there's a 7.92 millimeter pitch version. By taking advantage of this option, you can still keep the connector size small while increasing the pitch above 7 millimeters, which I hear all the time. Most battery applications are all at lower than or lower than 48 volts DC. When we get above 50 volts, applications may call for a finger-safe IP20 requirement, when the circuit being used must remain energized during connector usage. What this means is the operator's fingers are protected from accidental exposure to high voltage contacts. The definition typically comes from IEC 61984 or UL 1977, and the requirements are based on a finger probe that will be used for both a mated connection and when the connections are in an unmated state. NFPA 70E, along with several other standards, have requirements with regards to finger-safe installation, so make sure you have a clear picture of which standards apply for your application. For a product such as the Hirose DF60 series with an AC/DC 600 volt rating, a finger-safe rating may be important for your application, especially if those contacts are exposed to the user. Here we can see an example of a probe and how that probe may interact with the connector. We must consider all access areas, including these at the back of the connector where the wires enter the housing. Earlier, we discussed the ambient temperature as a part of the current ratings. Now let's touch briefly on another area of environmental concern, and that is the IP rating. Yes, power connectors are available with an IP seal option. All of the same parameters apply with regards to the voltage and current ratings. We just need to understand what that environment will be. Here we can see an example of the different IP ratings, all in a big chart here. When folks say that they're looking for an outdoor connector, they are typically referring down the bottom here to IP67 or IP68 requirement. But don't discount the other options. Just because a connector or device is rated to IP67 does not mean it passes IP66 water jet testing. Since IP ratings are an extensive conversation, we're just going to leave it at this chart for your reference right now. If you have more questions, talk to us about your application, and we will work with you to find the best connector option. With all that we have covered today, there is one last thing I want to mention about connector ratings before I move on to board-to-board power, and that is crimp quality. Regardless of the ratings listed on a datasheet or technical specification, if that crimp is not done right, the connector will not support the rated current that you expect. There is an amazing amount of technology in what seems to be a simple crimp connection. Here we see an example of what can go wrong with one of these things when working with higher current values. Crimp quality starts off with selecting the right wire and contact combination. The insulation thickness, diameter, and material can be critical to getting the right results from your crimp. This burned out connector was a result of the wrong wire gauge, incorrect insulation thickness, and a poor crimp, all combined together. These three things could have resulted in a fire. As you can see in this picture, wasn't very good. So choose wisely. As discussed in detail earlier, a properly sized contact will handle the required current within your application. However, it must be paired with the correct wire. If the insulation is too thin or too thick, the contact may not crimp properly. Here we can see a series of images showing common crimp issues and when you're reviewing a cross section on those connectors. This last image, this one here, this is of a good quality crimp. And what you can note here is the even shape of the contact body, and you can also see that the conductor strands are all compressed together properly. Air gaps are minimized, and the material is evenly dispersed within the crimp. Crimp tool plays a critical role in the making of this contact and getting it right, making all of this happen. Hirose offers a line of both hand tools and applicators for usage with our contacts. We also have partners both in tool making and cable termination that we work with. A list of these can be found on our website. We even have a loaner tool program for engineers to crimp contacts during the design and development phase of a project. Using the right tool will allow the full potential of a contact and connector combination. Fewer damaged contacts also means higher production throughput, which helps with the total cost of manufacturing. Finally, I want to mention board-to-board connectivity as it relates to power connections. Traditionally, these connections were either data or power, but not both. Designers would combine contacts together and when they needed to deliver more current than just what a single contact could handle. Today's board-to-board connectors offer many choices for combining power and data into a single connection. This improvement allows you to gain space savings and reduce complexity in your design by only using 1 or 2 power contacts instead of 10 or more. By taking advantage of structural space at the ends of the connector body, we have added power contacts to support significantly more current than the data contacts ever did. With products getting smaller, budgets tightening, the option to combine these two systems together solves both space and cost issues. We still have an excellent set of options for power-only contacts, so again, this is where talking to us about your application might help you narrow down the focus and get the best possible option within your design needs. Hirose's expertise in connector design allows us to both miniaturize the physical envelope and improve the electrical properties concurrently. We have covered lots of information today, and I hope this session has helped you understand the key pieces of information needed to select a power connector for your next application. As always, the teams at Hirose and Orion are available to assist you for your next connector project. Thank you for your time. Have a great day.
Great presentation. Thank you, Dave. We appreciate it. That was very enlightening. So, folks, we're going to actually permit you to download a couple of documents. These documents refer to a number of families of products offered by Hirose, namely Enerby, SnapBee, and SignalBee. And maybe Dave, you would like to elaborate on, just give us a quick summary of these families of products.
Sure. Yeah, absolutely. Thank you, David. So the Enerby series, that is our larger power connectors. So typically, most of the Enerbys really start in that, I'll actually say about 15 amp range and then go up from there. And then our SignalBee gets its name it's a mixture of signal and power applications. And you're typically going to see sizes, we'll say above 1 millimeter pitch and currents up to around 5 amps or so on the peak. And then SnapBee, that's probably our latest release family. And that product will be much smaller, designed for some of the micropower electronics or small battery applications that we're seeing. So that's the SnapBee family. Typically, vertical insertion is what you see in that family. You'll also see some of our smallest families, smaller wire gauges, 30, 32 wire gauge type sizes.
Gotcha. Thank you very much. Okay, folks, so these documents have been shared with you. And again, if you need additional information, please contact Orion Technologies and or Hirose. So we will now proceed with the Q&A. Dave is here to answer any of your questions. So please, we would appreciate your questions.
Now they get all typed there, Dave.
Well, your presentation was a great presentation. You've answered all the questions, I guess.
That's terrible.
It is indeed.
Well, what we're taking while folks are typing out some notes, Dave, if you don't mind, I'm just gonna hold up here our connector selector, which is available from your Orion rep. And basically what this is, it's a book, the small book that has all of the products within it laid out based on size, pitch, power products, data products. They're all in here. Great, easy access reference point. And we have a digital version of it as well.
That's right. We actually have a digital French version for those who are
that's right,
who are French speaking. So we actually have our first question, Dave, and the question is,
I'm nervous.
Do you offer any floating hybrid connectors?
Yes, actually we do. One of the last pictures, and I'll try to bring it up here so that you can see it in the background here. One of the pictures that I had brought up at the very end of the presentation was one of our hybrid series. So let's see if we can pull that back up here, and you can see it here behind me on the picture. What you'll note about this connector is that the two halves actually have the contacts actually float in the center. So you can actually take the product and you can move it around. This is super important if you're putting more than one connector on a board. And, specific for this, power connectors, you'll note on the end here, right here, there's a power contact. There's actually 4 power contacts on this connector. And the standard rating is 3 amps, but depending on what you're running through the center, we can actually design this in applications that go up to 5 amps per contact. So that's a pretty cool product.
It is indeed. Any other questions, folks? Going once, going twice. Oh, we have another question just in time.
More questions. Great.
All right, here's the question. If the ambient environment is cooler than 25 degrees C, can we pass more current than Hirose's recommendations through the connectors?
Awesome question. So let me just put out at first. We typically, when you want to push the envelope on a connector, we're going to want to know about that. And reason why is because there's actually come other factors with regards to the contact itself and how it dissipates that heat. So even though the ambient is lower, and you're right, that means that you can, in theory, dissipate more heat to the environment. But you'll notice, let me pull up the curve here, and so you can see that. And you'll notice that the curve actually flattens out a little bit if we were to look over here at the top of the line, you notice it actually flattens out quite a bit as the temperature goes down. So there's not any real major advantage there, because eventually you hit a limit on how well that contact is getting its heat out to the environment. There's only so much that it can move out to that outside environment. It was an awesome question, though.
Yep, absolutely. Any other questions, folks? Okay, I guess we will end the webinar. Once again, we would like to receive some responses with regards to the little survey. We truly appreciate your feedback, and we thank you very much. Thank you very much, Hirose. Thank you very much, Dave Gallagher, for the great presentation. And we'll see you folks soon. And thanks for showing up.
Thank you, everybody, for your time today.